Okay, everybody, here we go. We're going to start working on the derivatives of exponential and log functions. And this is something that I thought we could do on a video lesson because it's just a skill. And so it's just about you knowing the rule and knowing how to apply it to the derivative. So this part 1 is about the derivative of ln of any quantity. So we want to find the derivative of y equal ln of any quantity u. And I want to remind you that the ln of u is the log with a base of e of any quantity u, and this u just stands for some function that you already know how to take the derivative of. Alright, so before we do the derivative of that, I want to remind you of some log properties that could be helpful to you as we go through and apply these derivative rules. These you did in GT10 or college algebra. So remember that if you have the log, any base, and I'm just going to write them in terms of ln because we have a tendency in calculus to use ln more than any other logarithm, of the product of two quantities, so AB. Remember that's the natural log of the first factor plus the natural log of the second factor. And remember why that is. Logarithms are just exponents, so when you multiply two quantities that have the same base, then you're adding their exponents, and so that's where this rule is coming from. Remember there's also the ln of the division of two quantities, and that's the ln of the numerator minus the ln of the denominator. And there's one example of a derivative that I'm going to show you where this property is helpful. And the last property, remember, is when you have the ln of a quantity, and that quantity is raised to the power. Not the whole thing is raised to the power, just this argument. So then you get n times the ln of a. So remember, you could pull that exponent on the outside and multiply those two exponents together. Alright, so that top half I'm going to want on a note card. I'm going to do the rule for the ln, and then you can pause the video after this slide and write your two note cards. I want one note card on the properties and one note card for the rule. So the rule says if y equals the natural log of any quantity, so the natural log of u, then the derivative of that is 1 over that whole quantity times the derivative of that quantity using the chain rule. I'm going to do several examples on the same video, but I want you to pause it right now, and I want you to write the two note cards based off of this first slide. Right? Alright, pausing away. Alright, so the examples that we're going to do are as follows. Alright, we're going to do some simple ones, just simple ones, but be aware that all of the derivative rules that we already know are still in play. Like the basic 7 rules, the ground floor rules that we have, the product rule, the quotient rule, all of them are still in play. All the trig rules are still in play. And so this is just a new one that gets added to the list. So for the examples, we're just going to find dy dx for each one. Alright? So the first one is y equals the ln of 3x minus 2. Alright, so when I'm looking at this, it's just the ln of a quantity. I'm just going to apply the new rule. So the derivative is 1 over this whole thing. This is u right here. So it's 3x minus 2. And then you multiply by the derivative of just u, which is right here, the derivative of 3x minus 2, which is 3. And so rewriting that in a more observable form is 3 over 3x minus 2. Done. That's the derivative of the ln of 3x minus 2. That's all there is to it. And now we just apply it with everything else that we know. If I have y equals x squared times ln of 3x, then I'm looking at this, and this is x squared times L, that looks like an H, but it's an M, x squared times the ln of this. Right? It's not just the ln, it's the product of two things. So how do I start? I start with the product rule. So the derivative will be the first piece, which is x squared, times the derivative of the second piece. So the derivative of the ln of anything is 1 over that whole inside times the derivative of the inside, which is 3, plus the second piece, which is ln of 3x, times the derivative of the first piece, which is just 2x. And now we're going to simplify, right? So these 3's will cancel out, and I get x squared times 1 over x is just x, plus 2x times the ln of 3x. And notice that there's an x in common, so I can factor that out, and I get x times 1 plus 2 ln of 3x, which is fine with me. But if you notice, this 2 is on the outside of this, so technically this 2 can be the power of that. So if you wanted to, you could write it as x times 1 plus the ln of the square of this, which would be 9x squared. Either or, you never know which one is going to be on a multiple choice, but you just have to be aware that it's a log, and all of those log properties that I gave you at the beginning are still in play. All right? All right, let's do another one. If I can get a new slide here. All right, so example, y equals the ln of the sine of x. Ooh, yay! Yay, yay. So we have a trig function. So the rule is still the same. It's just the ln of that quantity. So I'm going to get 1 over that quantity, so the sine of x, times the derivative of the sine of x, which is cosine x. So we get cosine x over sine x. Are we going to leave it like that? No, because that is cotangent. So the derivative of the ln of sine of x is cotangent x. Done. And one more, if we have y equals the ln of x plus 1 over 3x minus 2. All right, so here's the one I was talking about earlier, that this is the ln of a quotient. And there's a log property that will allow you to split that up. And if you do that ahead of time, the derivative is a lot easier than if I keep it in its current spot. Because if I keep it like this, I have to do 1 over this times the derivative of this, which would be the quotient rule. And if I say, wait a minute, this is a log, so I can rewrite the original problem as the ln of x plus 1 minus the ln of 3x minus 2, then the derivative of this is a lot easier, because then I can just say, all right, the derivative of this is 1 over this quantity times the derivative of that quantity, which is 1, minus 1 over 3x minus 2 times the derivative of that, which is just 3. So I would get 1 over x plus 1 minus 3 over 3x minus 2. Now, in this whole unit, there are going to be times where I'm going to let you, leave it in this form, but this one's easy to get a common denominator and easy to simplify. So common denominator is x plus 1 times 3x minus 2. So this 1 gets multiplied by 3x minus 2 minus 3 times x plus 1. And when you simplify that numerator, the 3x's cancel out, and you're going to get negative 5 over our common denominator. Alright, so I'm going to check this video out to make sure that it worked. I did one already that didn't work, and so we'll see if this one works. I'll post this one. The assignment that goes with part 1 is on the worksheet or the handout that I gave you, and I'll talk to you soon. Bye.